So Shining 3D just reached out to me and asked if I wanted to play around with their brand new 3D scanner, the Einstar Vega. And of course I'm going to say yes to that. But little did they know, I already had an Einstar. The original Einstar. Yeah, the names are confusing. We have the Einstar Vega and we have the Einstar. It's like a self-titled album or something. But do you know what this means? It means it's time for
Einstar versus Einstar! Battle of the 3D Scanners, Part 2, Electric Shineroo.
In the left, we have the Shining Einstar.
Wait, are you trying to be a ref or something? The stripes on your shirt are wrong.
Really?
They're supposed to be vertical.
Crap. On the left, we have the Shining 3D Einstar. Coming in at 600 grams, its vertical cavity surface emitting lasers are able to capture a point cloud resolution down to 0.1 millimeters. With an effective range of 160 to 1,400 millimeters, you get a wide range of scanning for any object that you might want to throw at it. But can it keep up with its competitor, the brand new Einstar Vega? On the right, we have the Vega coming in at 700 grams. But with those 100 additional grams, you get a built-in battery and a touchscreen interface, meaning you can ditch the laptop and scan objects without any wires getting in your way. This scanner doesn't have one, but two different 3D scanning technologies with the same vertical surface cavity emitting lasers that the predecessor had, but an additional MEM scanner giving you ultra-precise close-range scanning with a point cloud resolution of 0.05 millimeters. That is past what your 3D printer can do. That's like you're machining metal on a mill at that point. Holy crap. Now, the effective scanning range of the Vega comes in at 100 to 300 millimeters on its MEM scanner and a 350 to 1,500 millimeters on the vise lasers. But these are just specs on numbers, so how will these scanners compare? There's only one way to find out. It's time to fight! So it turns out that scanning a bunch of objects with fog machines and lasers and dim light isn't the best scanning conditions, so I went ahead and rescanned all the objects under more normal conditions. Who would have thought? We'll go into the scans later in the video to compare their accuracy and quality, but for now, just enjoy the process. Out of all the objects we scanned, this 1, 2, 3 block is definitely going to be the biggest tell of accuracy. It's precision ground and meant for CNC milling. I'm using a granite surface plate and a dial indicator to get some accurate measurements of it first. Since the block is shiny, I'm using some 3D scanner spray to make a better surface for the scanner to pick up. Another cheap solution for this is to just dust some flour on the object, assuming you can wash it. This stuff just evaporates away cleanly. Okay, so we have three objects we're testing. We have a 3D printed XYZ block. Then we have a precision ground 1, 2, 3 block, that's the metal one. And then we also have the little mascot that came with the scanner. Each object was scanned twice. Once with the close range HD mode and once with the fast mode. Now, the original Einstar doesn't have hardware for a close range mode, but it does support a close range mode in software, so we're also going to see if that's even worth using. Yeah, the fast mode on this is insane. Literally, you just circle around the object, it doesn't lose track. The data, at least on the point cloud, looks to be pretty good. Obviously, we're going to have to throw this in software, process it, turn it into a mesh, and then we can compare it. But from what I'm seeing, pretty happy with this. We're also going to test some bigger objects like this vise. Amazing. No tracking dots. And I don't see any inaccuracies. To give you some reference, this is what happened when I tried doing a texture scan with the original Einstar. It lost track multiple times, and then looking in software, yeah, there's some pretty obvious misalignment on the vise. It didn't have the same issue using tracking dots, so that's good, but the Vega didn't have problems at all, so win for the Vega. Okay, now back to the Vega, with tracking dots this time. Well, I would say that was probably the least painful scan, and probably the best looking one from the point cloud. Very good model. Okay, look at that flickering. I'm only including that for a small part because it's very annoying, but if you're doing texture scanning with the original Einstar, that flickering shows up on film. There's also this annoying whine whenever the scanner is plugged in, even when you're not scanning. I've boosted levels just so you can hear it clearly, just for this one part. Just know that if you plan on doing content creation. After doing those last two scans, I was upstairs thinking about what else I could scan that's big and impressive. Doing some research, it seems like cars are common to scan on YouTube, so maybe I try that? Magic voiceover voice. My car's parked out on the street and I don't have power out there. The Vega could do that because it has a built-in battery, but the normal Einstar couldn't. That would be a terrible comparison for the video. Well, you just did a comparison. The Vega can do it, but the Einstar can't. Okay. Yes, you're right, but visually it would be a terrible comparison for the video. Yeah, but aren't you some kind of like methodical maker? Can't you just figure it out? Yep. You know what? Sure. I'll go figure it out. There you go. Good job, buddy. All right. I hope you're happy, Magic Voice over me. Got a giant lithium-ion battery that can deliver more power than a house can draw from its breaker box. And I got a massive inverter to power the Vega with. I mean the Einstar, right? And does it really need that much power? No, it doesn't need this much power, but this is what I have on hand, so I made it work. That's not quite what I meant. It seems excessive. Yeah. It weighs like 60 pounds. The Vega weighs 700 grams, which is like 1 pound. At least I can scan my car with this. Well, good job. Guess you gotta take it outside now. Yeah, I'll go move it to the car and do the scan. So through the power of editing, we're just gonna fast forward through the entire process. But I'll jump in and tell you how it went. Well, as you can imagine, the classic Einstar was quite the setup. And with all those cables, it kind of meant that it was easy to get a cable in the scan, which meant that you had to start all over again. As far as the Vega, it was pretty painless. I mean, the thing's just battery powered, you turn it on, you do the scan like normal. I will also say that it seemed to do better at keeping track of the marker dots and the bright sunshine. I'm not sure if it was necessarily that or just the lack of cables and being easier to move around, but overall, it was a better scanning experience, as you could expect. Okay, while the other me drags all that stuff back inside, let's go over the UI on the Vega. There's 2 buttons on the side. One switches between a light and dark mode, and the other one's just a normal power button. Sorry for having to film a screen like this, but there's no display out on the USB-C, so this is the best we got. Up top, you can switch between the HD mode and the fast mode, and then on the left, you can open this little menu up to adjust your brightnesses. Up top, you have the depth camera for the actual 3D scanning, and on the bottom, you have the vision camera for texture scanning. You just tap on the top and bottom of the pictures to adjust the relative brightnesses. There's also this button on top where you can switch between outdoor mode and indoor lighting. If you're on indoor lighting, you can also just tap the picture to turn on the flashlight on the back of the scanner. Opening up this next menu, you can adjust your scan distance. This menu is dependent upon the resolution setting. I'll touch on that in a second. And then down here, you can change between the data quality indicator and the texture view. The data quality indicator is probably what you want to use. On the right-hand side, we can open up our actual scan settings. We have object and portrait scanning, our resolution, whether or not we want to acquire texture, and then the kind of alignment we want to use. For this UI demo, I'll just keep it on feature alignment. One thing to note, we have low scanning resolution right now, and if we open up the range menu, we get a scanning range from 350 millimeters all the way up to 1,500 millimeters. If we change the resolution to be high, and then reopen that menu, you'll see that we're now limited from 350 to 750 millimeters. If you're wondering why you have that option to change the range in the first place, well, it's because sometimes you don't want to scan the background behind your object, so if you can dial in your range, that means there's less data cleanup afterwards. I'll go ahead and switch over to HD mode, and you can see that the scan settings are pretty much the same, and you can see that the range slider has updated as well. We'll go ahead and start a scan, just as easy as hitting the play button, and then you can see that we're now capturing data. I'll just do a quick little capture to get something for the screen. Again, this is just going over the UI. I'm not trying to get the best scan possible. The studio lights definitely don't help. And weird. Wonder how that got there. Subscribe? Anyway, you can scrub through the data with this little slider on the bottom. Let's say you scan a part of your hand or something you didn't mean to. You can pause the scan, go back, get rid of the data that you don't want, and then hit play and just continue scanning. Once you're done with your scan, you just go ahead and hit this little checkbox and it will optimize the point cloud. This is a pretty quick process, even on larger models. On the left, you have a button where you can do some data cleanup, and on the right, you have a button to do meshing on the device. That being said, you can also do the meshing on the same software that you use on your computer to import your models. Not only will it go faster, but you also have a mouse and keyboard at your disposal for any data cleanup you need to do. That being said, it's a cool feature that they included, especially if you're going to be scanning at a remote site where you don't have your computer. Moving on, looking at the top, we see the current RAM usage, the battery, and the version that the scanner is on. Super useful stuff. Swiping down, we can see it's running Android with our Wi-Fi, our storage, and our screen brightness. There's also a nice big button to recalibrate the device here. Looking at the settings, everything's pretty laid out, straightforward. There's no real menu diving that you have to do, which is great to see. So with all the on-device stuff covered, let's move over to the computer and look at the computer companion app called starvision. To get started, connect the Einstar Vega to your computer over USB-C. You can go ahead and click the scanner, and see all of the scans that were done on it. For a demo, we'll be using this scan right here. I'll go ahead and click the scan. We can look at the point cloud or the mesh if it does have a mesh, and then we can import it to a workspace. I'll go ahead and choose a new workspace and click create. On the left-hand side, you can see the model, both the mesh and the point cloud, and you can select between both of them. Super cool. On the point cloud, we can see that we have a few options here, such as cropping. If there's data on your model that looks incorrect or that you don't want to include in the model, such as a surface it was scanned on, you can use this feature to quickly get rid of that data. Okay, so there's still a lot of floating data on this model. If you were doing this for real, you'd probably want to go in and remove all of it, but surprisingly, I found the built-in tools work pretty well at filtering all of that out. So I'll just do one-click processing, and I'll choose to do this on high resolution. And you can see that the resulting scan is quite detailed. I made sure to purposefully leave some holes in this model so we can take a look at the built-in mesh editing features in starvision. Opening up this page, you can see that we have simplify. You can also adjust your smoothness, remove isolated floating data, and fill holes. We'll use the fill holes option. We can move this slider to select holes automatically, or you can shift click to choose a single hole that you want to fill. You have a few different options for how to fill the holes. So for instance, on this one, I'll choose curvature, and you can see that the software did a pretty good job at filling that hole. Then we can go back into the menu and we can just use the slider to automatically fill all the rest of the holes on the model. We can see that the software did a pretty good job at filling all of those holes. The ones down here at the legs are just a little bit too big to fill. If we look at the torso, it did a pretty good job. Filling the holes on the bottom of an object like this would really be done by aligning multiple scans. So let's go do that. I'll go back to my models, and this time I'll pick 3 models. I will import all of those into one new workspace. I'll go one by one using the cropping tool to clean up the floor and any extra data on the models. Once that's done, we can go to the alignment tab and we can choose our models on the left-hand side here. If you have markers on the object, you can use the marker option, which makes alignment a little bit easier. However, since this scan was done with the markers around the object and they don't move with the object, we just have to use feature alignment. Simply click the alignment button and then make sure everything looks good in the bottom window. If it does, you can click add to list, and then you can choose your alignment result and the other model that you didn't align yet. We can then close out of this and look at our newly aligned model. We'll go ahead and just do one-click processing with high detail. And just like that, we get a pretty good looking model. Similar to before, we can use the cropping tool to clean up any little extra data that might exist. It looks like we still have a small hole in between the legs, but this time it should be much more manageable. We'll simply use the fill holes command again. And that looks a lot better. Cool, so now that we've seen what starvision's about, let's go look at the software for the original Einstar. Okay, next up we have exStar. To start with, I really dislike the UI of this tool. Under the hood, everything works great and it's all there, it's just the layout is a little bit hard to wrap your head around at first. So to get started, there's this top bar and you work left to right, but it starts you off in the middle. That's because when you disconnect the device, the button to reconnect it is here on the left, and then the calibration, which you've already done, is next to that. So kind of makes sense, but it's weird. The next thing to do is make a new project group. I'm going to call this Demo 6. Because this is the 6th time I've recorded this. So first off, the scanner makes an annoying whine, so it's wrapped in a towel. Kept forgetting to put it back in the towel. Also, because they use this weird window thing that they made, it wouldn't capture my mouse pointer. That's cool. The first thing we need to do is set up our scan options. For this, I'm just going to go with the default. One thing to note is that the new software does not have this global markers option, and I find global markers to be really useful. I've recommended them to add it, and hopefully it's there in the future. Basically with global markers, instead of scanning an object, you put a bunch of tracking dots down, and then you scan where the tracking dots are. You can save that file, and then you can just import it in every future scan you do. This is really cool because you can make a permanent or pop-up scanning setup. And basically, if you have tracking dots on the bottom, side, and back surface of where you're scanning, your scanner just never loses track. It's just a really good feature to have. So we'll go ahead and hit confirm, and now we can start our scan. Things like working distance you have to adjust here, but things like brightness and the zoom you can adjust on the scanner. So I'll show you that in a second. We'll turn off texture flashing because it makes a strobing effect, and we'll turn on the data quality indicator because, to be honest, that is the feature that sets both the Vega and the original Einstar apart from all the other scanners I've used. We'll use the top and bottom button on the scanner to adjust our brightness just until the object is starting to look a little red, and then we'll hit the middle button to start our scan. The next thing to do is do any data cleanup. Let's say we don't want this stuff that's over here to the left. We can just choose the lasso tool, select the data we don't want, and then go ahead and hit delete. When we're done, we need to build the point cloud. To do that, we go over here to the right and we click this button right here. Confusingly, if you hover your mouse over it and then move it to the left, there's two different options. I feel like this should be a drop-down menu or a right-click thing. I've never seen this mouse slide UI before. We'll just choose this one because it's faster. As for when to choose the second option, if you notice some slight misalignments in your data, you can try the optimize option. It sometimes can fix those alignments, but it does take longer and does require a lot more memory. At this point, you think you're probably good to pick up your scanner, hit the middle button, and start your second scan. Maybe you want to do some scan alignment or something. Sadly, that's not the case. If you do that, it'll just start adding more data to this scan. What you need to do is move from working with the right bar back over to the left bar and go to Project List. Here you can hit New Project. To me, New Project seems like I'm just going back to the beginning where I made a project group, but in exStar lingo, a new project is just a new scan. So clicking that, we can choose our options again and hit confirm. Once you have a second project, you can still view the data from your previous project by clicking this little eyeball, and you can make any modifications by clicking on the project. There is a difference between single and double clicking, but I don't really know what it is. Look, if I single click, it changes this bottom bar to look like I'm in the second project. If I double click, nothing on the screen changes, but if I try to double click project 2, I get a warning that says there's no data to edit. So when I single click on project 1, am I in the editing page for that? I don't know, man. I got project 2 selected. We're going to start the next scan and then do some alignment. Similar to before, we can do any data cleanup, such as getting rid of this stuff on the left. We can apply that, and then we can go ahead and generate our point cloud. So now if we go to the left, we can see we have two projects, and we can look at both of them. They're not aligned, so to do that, we go to the Alignment tab, and then we pick our two scans, or two projects in exStar terms. We can then hit the Apply button to align them. This is looking pretty good. Let's apply it and then move on to the next part of the process. So we're gonna hit Apply again, right? No, that just does what we just did. Yeah, to move on to the next step and actually apply the alignment, you hit the next button. That takes your scans and it puts it in this group up here. And I think that putting it in a group like this is actually better than what the newer software does. Assume you have 10 scans that you're trying to align. In exStar, every time you align scans, it just gets added to this group, and then you can pick the next scan to align down here in the bottom. In the newer software, it doesn't hide the previous scans that you've aligned, which means if you have a lot of scans to align, you're probably going to get confused on which ones have and have not been aligned yet. To move on, you hit exit, you can take a last good look at your model, do any last minute changes, and then you can move back over to the right hand side and choose to mesh the model. These settings should look pretty familiar to you. They're basically the same that's on the Einstar Vega, so we can go ahead and hit preview and wait for that to finish. If everything looks good, you can hit confirm, and it gives you a little warning that says, hey, if textures look wrong, all you have to do is click this little texture remapping button and it will remap them for you. You notice here on the left hand side that we have a bunch of mesh editing options similar to the newer software. It does look like there's more here, and that is true. There's ones like mirror, but a lot of them are just broken out. For instance, auto hole filling and manual hole filling are just one option in the new software. You can do any editing that you want, clean up any last little bits of data. Let's say you don't want that little floaty guy there, and then you can go ahead and export your model. You'll get one little pop-up again warning you about texture alignment. We can just hit cancel, and then we can save it locally. At this point, you get a file that you can put into a 3D printer slicer or your CAD package of choice. I think I hear myself struggling getting that battery back upstairs. I think we have enough time to talk about packaging really quick. And then, yeah, we'll get into looking at the models, I promise. Okay, so to keep it short, the packaging on these scanners is exceptional. I recently moved, and during my move, my personal Einstar fell down a flight of stairs. That's the Einstar Classic. And I was pretty worried about it until I picked up the case and realized, yeah, it's probably fine. Taking a look inside, the case is pretty much identical. On the Vega, you do also get an additional tripod, and it's a pretty nice tripod. Everything about it is aluminum, except for this little plastic bit where you'd screw it into your scanner. The tripod legs extend out, and even when extended, it is really stable and doesn't want to move around. Love to see it. The table moves, not the tripod. Great stuff. Both cases have a little pouch where you can store your tracking dots. And in the back section, it unzips where the calibration board is stored. On the Vega, it does come with a calibration board holder. When you're doing the calibration with the original Einstar, the first step is to go straight up, and then you have to go out on an angle. On the angled bits, it's a little annoying. It's hard to know if you're hitting the angle correctly. But with the Vega, you slip the board into the board holder, and then all the steps are going vertical. That's about it. So great cases. These are expensive tools, and you're probably going to be traveling with them, going to sites to do scans, especially if you have the portable handheld Vega. Great to see that there's a really nice case to store it in when you're traveling. Okay, let's go check out the scans. We have a lot of scan data to go over. I'm going to save the best for last, but I think all these models tell a pretty good story. To start with, let's go over the XYZ blocks. On the bottom, we have the original Einstar, and up top, we have the Einstar Vega. Starting with the original Einstar, we have 3 scans. We have the close range mode with scanning spray, and then the far range mode. Starting with the close range scan, you'll notice that there's some problems. Pretty much all the edges have a little bit of overshoot. There's also some extra data above the Z up top, and there's some data missing from inside of all the letters. Now, the data missing isn't necessarily that big of a problem. Whenever you're 3D scanning, getting data inside of holes is always going to be a challenge. What is a problem though, is the edges where the X, Y, and Z aren't really all that crisp. They're all a little bit blobby on the edge, which means that trying to pick up that edge in CAD to reverse engineer is going to be a challenge. You can always measure the depth of the hole with a pair of calipers and use that in your reverse engineering, but having a sharp edge really does help on recreating that geometry. Moving on to the scan with spray, it's basically a similar story. The edges are a little bit more crisp, but there's still area to improve. The overshoot went away other than in a few little areas, and there's still some extra data above the Z. Going to the far range scan, while yes, the letters are filled in, we still don't have a sharp edge, and the overshoot problem became even worse. Thankfully, the Vega solved almost all of these issues. Starting on the right, we have the far range scan. While yes, it was able to fill in the letters, I'm not really considering that better or worse. What I do think is better though, is that the edge on the X is more well defined. While it's not as good as the close range mode, this is a much bigger improvement over the original Einstar. We still have a bit of a rough texture on the surface, which isn't true to the object that we scanned, but we do see that pretty much all the overshoot has gone away. Moving on to the HD scans, we get a much better model. The first thing to notice is there's small rippling on the actual model itself. Now, that's the 3D printer layer lines that the scanner picked up. Quite impressive. We see that there's a sharp, well-defined edge on the X and on the Z, and there's no extra data or overshoot on the model. I processed the same model in 3 separate ways. First, using the recommended settings of 0.14mm resolution, and then again using 0.1mm resolution with and without texture smoothing. Looking at the 0.1 resolution, we see that there's even more well-defined 3D printer layer lines, and other than that, the model is basically the same. If we compare the model processed with and without surface smoothing, we'll see that on the one without surface smoothing, there's a little bit of extra junk data around the edge of the Z. Looking at the model with a bit of surface smoothing applied, we see that a lot of that junk data gets removed. Really cool to see that the software processing actually helped with this model instead of hindered. Thankfully, the Vega software makes it really easy to go back and try different settings and quickly decide which one is best for the scan that you've done. Moving on to the vices, we have the texture scans, with the Einstar Classic on the bottom and the Einstar Vega up top. Looking at the models, you get a good bit of detail on where the logo for the vise is. The workbench it's on, you can see that there's a small misalignment on the wooden boards, really cool to see. What we can notice on the original Einstar is there's a little bit of overshoot here on the soft jaw of the vise. We'll also notice that it struggled on some of the more shiny parts of the vise, such as the handle, the bolts, and this back post. While that's to be expected and can be fixed with scanning spray, it is worth pointing out that the Einstar Vega did do a better job in this regard. You'll see that all the bolts are more well defined, more of the back post on the vise was picked up, and the handle, at least the part that I scanned, has less holes in it. Looking at this side of the vise, you can see that the logo on the vise did still come through really clearly, and it was able to pick up more of that back post. One good thing to note on the Vega is it didn't have any overshoot on the soft jaws of the vise. If we look at the front surface of the vise right here, we'll notice that the vise has like a hammered textured paint job. Moving the lighting around, you can see the texture came through pretty clearly. However, on the classic Einstar, you get a lot less of that texture coming through. This really shows me that the Vega is picking up a little bit more detail in its scan. Next up, let's look at the scans using marker dots. Personally, I use marker dots for almost all the scans that I do, so I think this is a little bit more telling. Looking at the classic Einstar down on the bottom, we'll see that we still have some overshoot on the soft jaw of the vise. Besides that, the detail of the table's still there. You can see that small misalignment in the wooden boards. Some of the bolts are missing some data. Obviously, shiny surfaces are always rough for 3D scanning. Same with the bar here to tighten up the vise. Looking at the side, we get some really good detail on the logo, and the back post didn't really get scanned all that well. Again, it's shiny, so that makes sense. Moving up to the Vega, it did a much better job capturing those shiny surfaces. All the bolts are defined, the back post is more well defined, and even the bar for adjusting the vise is a little bit better captured. The logo is still clearly visible, and you'll notice that the soft jaws do not have any overshoot on them. Really nice to see. Both 3D scanners did a really good job at taking the marker dots and blending them into the surface of the vise. If we go back and look at the texture scan, you'll see that all of these little marker dots are clearly visible in the scan data. It is cool that the scanners are able to pick up on the thickness of a sticker, but it's also really cool that the software is able to completely hide them when you use the marker dot mode. Looking at the surface quality on the vise, you'll notice that hammered paint texture really comes through well on the Vega, and while it is still kind of visible on the original Einstar, it's not nearly as clear. All in all, a win for the Vega. Looking at the car scans, you'll notice that the original Einstar has a lot less data captured. While it was able to capture data in the bright sunlight, I definitely think that the Vega did a better job, which is why we have more data overall in the scan. You'll notice there's a hole in the Subaru logo, and the Vega did a much better job at capturing the detail of the logo, and it didn't have a hole in it. The main thing I was trying to focus on in the scan was the back spoiler on the car. The classic Vega had one small hole, which the software did a pretty good job at filling, although there is a small surface blemish right where my mouse pointer is. However, the Vega had no problem whatsoever and got a really good capture of the entire spoiler. If we come around to the back side, you'll notice that the classic Einstar had trouble picking up this back edge. I think that's for two reasons. One, like I said earlier, the scanner had a little bit more trouble tracking the object in the bright sunlight. The second reason is with the battery and all the cables and having to look off to the side at my laptop screen, it was harder to see what I was capturing, and it just didn't pick up the back surface where the spoiler meets the car nearly as well as the Vega did. Taking a look at the Vega, you can see there was no issue in that regard. It captured a really good scan, and all of that detail where the spoiler meets the car is there. Again, another win for the Vega. Okay, let's move on to the 1, 2, 3 blocks. On the bottom, we have the classic Einstar, and up top, we have the Einstar Vega. On the left, we have the far range mode, and on the right, we have the close range mode. Starting with the far mode on the classic Einstar, you can see there's a lot of overshoot at the top of the object here. That's not great to see. With the close range mode, a lot of that disappears, which is great. The close range mode also seems to have better flat surfaces than the far range mode. Moving on to the Einstar Vega, we can see that the far range mode did capture the object well, although it is a little blobby. I think that's really coming down to just it not having as dense as a point cloud around these holes, and the software just trying to kind of stitch together what it has. That being said, you wouldn't use the far range mode on an object this small, so let's look at the HD mode. And wow, yeah, that's done a much better job. You can even see some of the screw threads in the holes. Really cool. Now, I only scanned from the top, so the underside of the holes, those just got filled in software, but looking down from the top, yeah, there's threads in those holes. Really impressive. The surface is also really smooth. Yeah, there's a little bit of texture on the model, but that's because for these scans specifically, I turned off any texture smoothing because I wanted the most accurate model for doing measurements on. So really good scan. Speaking of measurements, let's take some. Starting with the classic Einstar in close range mode, we get a thickness of 25.1 millimeters. We expect to see 25 millimeters, so this is an error of 0.1 millimeters. For reference, that's about the thickness of a single sheet of printer paper. Next up, we have the classic Einstar in the far range mode, and we get a similar error of 25.1 millimeters. This makes sense because the close range and far range mode on the classic Einstar is just a software setting. It's using the same exact hardware. Moving on to the Vega in far range mode, and we get an error of about 0.9 millimeters. Now, for an object this small, you'd be using the HD mode and not the far range mode, but we can extrapolate this out to an object that you would be scanning with the far range mode. Let's say a table or a closet if you're trying to do some woodworking. And for that, a 0.9 millimeter error is pretty dang good. So cool, but realistically, you'd be using the HD mode scan for this. So let's look at that. Taking a look at the HD mode on the Einstar Vega, and we get a measurement of 25.15 millimeters, so 0.15 millimeters oversized. Okay, so we still have a few models to look at, but just off of this and the accuracy, I would say that the Einstar and the Einstar Vega both do a pretty good job at scanning objects from a dimensional accuracy standpoint, but since the Vega is able to capture extra detail like the threads on the inside of these holes, it would save you just a little bit of time when it comes to reverse engineering. That being said, we still have the little mascot to look at, so let's take a look at that. So all the previous scans we looked at, such as the vices, were just done with a single scan. That's why there's some holes and stuff missing on the bottom of the scans. In contrast, for the mascot scans, I did multiple scans, cleaned up any data, and aligned them. I basically treated it as if it was a project that I was going to be working with to reverse engineer or 3D print. To start with, we have the classic Einstar in the far range scanning mode. You can see some text down here. You can make out that it says Einstar. You can see that there's some kind of logo on his jacket, and you can barely make out that it says 3D right here. You can definitely see the D on the jacket. I'm not so sure about the 3. Looking at his face, you get some pretty good detail on the eyebrows, but you can't really make out that there's multiple levels on the eyes itself. You can kind of see the pupil, but it's not well defined. The S on the helmet looks good. The fingers look okay, there's a little bit of floating data over here, and the scan kind of merged some data with his ear, or the side of his helmet. The base that he's standing on looks good though. You can see the pitting on the surface of the moon or whatever it's supposed to be, and the boots have some detail on the sides, although it's not super clear. Moving on to the far range of the Vega, and this is, again, not what you're supposed to be using the far range mode for, but I assume someone out there is going to do it, so I figure I'd cover it. You get a much worse scan. The text where it says Einstar is basically non-existent, the surface looks a lot more blended together, and the jacket is lacking detail. You can't see the 3D, you can kind of see that there's a button, but you can't see the logo on it. The S on the helmet is still well defined, and the text on the back is, yeah, it's there, but you can't really make it out. But again, you wouldn't really be using the far mode for a scan like this. Let's take a look at the HD scan. Maybe that'll look a little bit better. And oh boy does it. Look at the detail on this thing. I mean, down here where it says Einstar, you can see the gap between the I and the N super clearly. Going back down to the classic Einstar, that just gets blurred together. On his jacket, you can clearly see the 3D, and you can see the shining 3D logo on this little button. All of the details on the jacket and boots and pants are just impeccable. I mean, look at this hose right here. You can see all the little striations on it. The boots, same story. You can see the detailing on the side there. The eyes, you can make out each individual layer. The fingers are all super well defined. There's no extra floating data. The details on the backpack come through super clear. You can see each little box on the side of the backpack, where down here, it was just kind of like a line or something on the side. The text that says keep shining is super crisp, and same with that V on the backpack. Taking a look at the base that the model is standing on, the big pits come through on both the original Einstar and on the Einstar Vega, but what you gain is all of this really small intricate detail between the large pitting. If we zoom in, we can see that there's some intricate detail in the texturing here, but if we go down to the classic Einstar, it just kind of smudges it all together, and you end up with a more triangle-y polygon look over here, where here you can really make out all of the little pits and nooks and crannies on it. Super impressive on the HD scan. But this got me to thinking, if the HD scan can scan a small object this well, then how big of an object can the far mode scan? Well, I did a pretty big scan, and it kind of crashes Fusion 360 if I try to open it in it. So let's just jump back to starvision and take a look at that. Okay, this absolutely blew my mind. For reference, the classic Einstar, I did a scan of the cooler that was in my last video, the motorized cooler thing, and the scan of the cooler pretty much was the limit of what I could scan with 32 gigs of RAM in my computer. I just wanted to push the Vega to its limits, and it was able to scan an entire bedroom. Yeah, and I probably could have scanned more if I put tracking dots on the walls, but I just did a texture and feature mode, so basically flat walls, out of the question. But everything else, it scanned perfectly. So whenever I talk about 3D scanners on Reddit and Discord, people always ask about the iPhone. And yes, the iPhone can do 3D scanning, but it can't do up-close small object 3D scanning. It's like room scale stuff, the size of a wall, the size of a desk. In my head, purpose-built 3D scanners like the Einstar and the Einstar Vega, they don't exist in the same world as the iPhone. It's a different tool for a different job. But the Vega just flipped that on its head because it can do room scale scanning. And not only can it do room scale scanning, it can do it down to an accuracy of 0.9 millimeters as shown in our previous test. That means you could scan this room, maybe you want to make some custom furniture for this weird back nook over here, or maybe you want to make custom closet inserts. You can do that scan, put it into CAD, design the stuff that you want to make, build it, and then put it in the room knowing it's going to fit to within a millimeter. That is insane. And I think it's so insane that it probably deserves its own video. So if you think that would be interesting, let me know down below, because I have a bunch of other projects that I want to get back to after doing this 3D scan review, but if there's a lot of interest for this, I don't know, maybe I'll take the Vega out and do environmental scans and, maybe that'll be useful for a video game. Who knows? But this opens up a whole new world of possibilities, and I just wanted to include it because people should know that you can do this now with 3D scanners, with a handheld, portable 3D scanner. Insane. Okay, so with that out of the way, I'm super pumped and excited. Let's wrap this video up with a conclusion. But to do that, I want to use the big camera, because a scanner this cool deserves the big camera for the conclusion, not my webcam. So let's go. See you there. Okay, so what are my final thoughts? Well, before I get into that, I want to let you know that I do have an affiliate link in the description below, as well as a discount code, Methodical Maker, all one word, that'll get you $50 off. I don't get paid to do scanner reviews like this. Shining 3D was nice enough to send me their scanner, but after this review, I'm just going to be sending it back to them. So by using the affiliate link, not only do you help me recuperate a little bit of the time that a video like this takes, you also let Shining 3D know giving me cool hardware to play with gets it in front of people that are interested, which increases the likelihood of them giving me more fun toys to play with in the future. So yeah, check out that affiliate link, especially if this video helped give you the information to decide whether or not a 3D scanner is right for you. Okay, let's talk price. The Vega comes in at $2,000, and that's a lot of money. The good news though is the Einstar Classic comes in at $600 if you're okay with a refurbished model, or about $800 to $900 if you want a non-refurbished version. I personally bought my Einstar a year or two ago at a price point of over $1,000, and I've been really happy with it ever since. So if $2,000 is just a little bit too much, I do think that going with the Einstar Classic isn't going to make you unhappy. I really do see the Einstar as more of a professional tool that's just in the price point where it's at the upper end of prosumer. Maybe you're a carpenter scanning rooms to do custom furniture, or you're an automotive shop building custom bodywork or roll cages. The increase in portability and ease of use, both of the scanner itself and the software, is easily worth the extra $1,000 of this compared to the original Einstar. So it really comes down to your price point and what you want. If you want a scanner that's on the upper end of prosumer and is basically what a business would want to use, the Einstar Vega is not going to let you down. It can scan stuff ultra detailed up close, and it can scan things really large like the scale of a room. The software is much more intuitive and easy to use, and you won't need to go through any training or teach someone how to use the software. Really great if you're a makerspace or a shared workshop. On the other hand, if you don't have the budget for this and you're scanning more medium-sized objects, say the vise or a small engine, the classic Einstar has you covered. It comes in at a much cheaper price point of $600 or $800 to $900 depending on what model you want, and it will still give you really good performance. The only downside is you're going to have to learn some clunky software in order to get those scans to a usable state. The tools under the hood are all there, but the UI is not laid out in the most clear way. Hopefully, you can just watch the previous part of the video where I go over the software and figure it out based off that. So, as for me, well, I already own the original Einstar, and it works fine for my use case. That being said, this is a scanner that I wish I had, and in the next few weeks, while I still have this, I'm going to be doing tons of personal scans with it, so I have them all for the next upcoming projects. Alright, well that's all I got. Thanks for watching the video. If you have any questions about these scanners or the experience that I had with them, ask them down in the comments below. I'll make sure to answer them. I hope this video was informative and helped you decide if a 3D scanner was right for you, and as always, I'll see you in the next one.